Okay, finally in section 1.3, we want to discuss piecewise functions. These functions are very important in the study of calculus, and so there's a couple of things that I want you to be able to do with piecewise functions. So if you take a look at example 1, f of x is equal to two different possibilities. It can't be both of these at the same time because then it's not a function. So how this works is that on the domain x less than 1, the function takes on the name 3x minus 2. On the interval from x greater than or equal to 1, the function takes on the identity natural log of 3x minus 2. So that's how this works. We're not going to evaluate both of these at the same time. We're going to choose one or the other whenever we're answering questions. Okay, so if we look at letter A, f of 0 is what we want to evaluate. Well, we remember that f of 0 just means plug 0 in for x. But which of the functions do we plug into for f of 0? Well, f of 0 means that x is 0, and 0 is less than 1. And so I'm going to be plugging that into the first piece to get my answer. So 3 times 0 minus 2 will give me an answer of -2. Okay, for f of 1, 1 is greater than or equal to 1. So hopefully you see that little equal bar right there on that second branch of this piecewise. And so if we want f of 1, that's what we're going to plug into. So f of 1 is going to be equal to the natural log of 3 times 1 minus 2, which is equal to the natural log of 1, which is equal to 0. Okay, for f of 5, I know that 5 is greater than 1. So let me erase this so that may not be able to erase it for some reason, but if you look there, now you can see it. 5 is greater than or equal to 1, and so therefore I'm going to be plugging into the second piece, which is going to tell me that this is natural log of 3 times 5 minus 2, which is going to equal to the natural log of 13. Okay, now we also want to be able to figure out what limits are in regards to piecewise functions. And so for letter D, this says the limit as x approaches 1 from the left. And how I want you to think about that is numbers smaller than 1. Think about a number line. The left of 1, and the reason I know it's left is because of this superscript minus sign here. 1 from the left means numbers smaller than 1. And so what branch are we going to use if we want numbers that are smaller than 1? That's going to be the first function, the 3x minus 2. And so I'm going to plug in 1, but the superscript tells me which of the branches to plug into. So 3 times 1 minus 2 is equal to 1. Okay, for letter E, we have the limit as x approaches 1 from the right side. And so how I want you to think about that is numbers larger than 1, and numbers larger than 1 is going to be this second piece, the natural logarithm. And so this is going to equal to, again, I'm going to plug in 1. The superscript just tells me which one to plug into, so 3 times 1 minus 2, again, will be natural log of 1, which is equal to 0. Now, for letter F, you do not see a superscript. This is just the limit as x approaches 1. Here's how we do this. This limit in letter F only exists if letter D and letter E both exist and are the same number. So let me say that again. This limit here is going to exist if the limit as x approaches 1 from the left of f of x is equal to the limit as x approaches 1 from the right side of f of x. But because that does not, because that's not the case here in this example number 1, because this limit, which was equal to 1, is not equal to this limit, which is equal to 0, we say that this limit does not exist. Okay, finally on example 2, we want to basically do the same thing as example 1. F of -3 means that I'm going to plug into this first piece for x to get that value, and so this is going to be 3 times -3 plus 5, which is going to equal to negative 9 plus 5, or negative 4. For negative 1, f of negative 1, we're going to have to go into the second piece because that's where the equal bar is located on the inequality symbol. And so this is going to equal to the opposite of negative 1 squared plus 3, which is going to be negative 1 plus 3, which is equal to 2. And then finally, f of 2, since 2 is greater than negative 1, we're going to use the bottom piece. And so this is going to equal to the opposite of 2 squared plus 3, which is going to be the opposite of 4 plus 3, which is equal to negative 1. Okay, so hopefully you're getting the hang of how to evaluate these piecewise functions and then how to find limits. So for letter D, the limit as x approaches negative 1 from the left, meaning numbers smaller than negative 1, that's going to be the first piece. And so we're going to take negative 1, we're going to substitute it in for x into that top piece, and then we're just going to simplify. 3 times negative 1 is negative 3, plus 2 is plus 5, is equal to 2. And then letter E, the limit as x approaches negative 1 from the right. And so this is going to equal to, we're going to use the second piece, since negative 1 from the right means values of x that are larger than negative 1, but we are going to plug negative 1 in. And so this is going to be negative 1 squared, the opposite of that, plus 3, which is going to be the opposite of 1 plus 3, which is equal to 2. Now, notice that letter D and letter E were the same value. They both existed, meaning we could find the answer, and the answers were equal. Therefore, letter F, what we call a two-sided limit, because it does not have a superscript, either plus or minus, this limit is also going to equal to 2, and the reason for that is because the limit as x approaches negative 1 from the left of f of x is equal to the limit as x approaches negative 1 from the right of f of x, and both of those things are equal to 2.